Today we're going to be looking on how to write numbers in scientific notation. First, if you look at this slide, you will see a very, very small number and a very, very large number. And if you try to read those, they become very difficult to read. You have to take the time to figure it out and count place value. So what they have done in the scientific community is found a way to write very small or very large numbers in a way that's more concise, that's easier to read. So it was just developed to make it numbers easier to work with. So let's look at something here. This is on your notes. If you look at the top of your notes, scientific notation is a way to write very large numbers or very small numbers. We're going to look at some basic principles of writing numbers in scientific notation. First thing, when writing in scientific notation, the number must be between 1 and 10. So what that means is if you have a number like 325,000, that number is not between 1 and 10. But if we were to take the decimal and move the decimal from the end to right here after the 3, that would read 3 and 25 hundredths. Now the number is between 1 and 10 because it's 3 and a decimal. It's between 3 and 4. So you always want to have the decimal after the first non-zero digit. See how we move the decimal right after the 3 so that that number is now between 1 and 10. That's what that means. Also, when writing in scientific notation, the number is always going to be multiplied by a power of 10. And we're going to look at that in just a minute. Now, if you look at this example right here, 67 times 10 to the 5th power, this is not written correctly in scientific notation, and the question is why? Well, if you look back at the first thing, scientific notation must have, the number must be between 1 and 10, and this number is 67. So in order to write that in scientific notation, right now with the number 67, the decimal is at the end. We have to move the decimal so that would be 6 and 7/10. 6 and 7/10 is a number between 1 and 10. We would have to add one more to our exponent. We'll look at that in a minute. But always make sure the decimal is after the first non-zero digit. Before we write in scientific notation, let's just understand some things about the power of 10. When you have 10 to the 4th power, that is the same thing as 10 times 10 times 10 times 10. And what you will find out is that 10 times 10 times 10 times 10 is the number 10,000. I want you to look for a pattern here. Notice in the number 10,000 how many zeros there are, and look at the exponent. When we have 10 to the 7th power, if we go 10 times itself 7 times, we are going to have the number 10 million. Notice the number of zeros and notice the exponent. So when you have 10 raised to a power, the exponent tells you how many zeros is going to be in that number. Now let's look what happens when we have a negative exponent. Yesterday we looked at negative exponents and we said that we cannot have a simplified answer with a negative exponent. So we had to take it and move it to the denominator, move it downstairs. So we'd move this down, that'd be 10 to the 3rd power. Well, we just talked about that if you have 10 to the 3rd power, that is a 1 with 3 zeros, which is 1,000. So 10 to the negative 3rd power, when simplified, is 1,000ths. Well, how do we write that as a decimal? That is written 0.001, 1,000ths. So we're trying to look for a pattern here like we did with the positive exponents. Same thing with 10 to the negative 6th power. If we get rid of the negative exponent and move it downstairs, you're going to have a 1 with 6 zeros. 1, 2, 3, 4, 5, 6. That is the number 1,000,000ths. So when writing that decimal, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Okay, there's what that number is. And let's look for a pattern. Here we have a -3. We know it's going to be a decimal, a very small number. Notice how many digits are after the decimal. 3. When we had a -6 exponent, notice how many digits were after the decimal. 6. So there's a pattern there. Okay, so if we're going to write 100 million with a power of 10, all you do is look at how many zeros there are. There are 8, so we write it 10 to the 8th power. This is a decimal. Remember, we count the digits after the decimal. 1, 2, 3, 4, 5, 6, 7. So that'd be 10 to the -7th power because it was a decimal. Here we see a large number with 5 zeros, so that would be 10 to the 5th power. Here we see a decimal, a very small number with 4 digits past the decimal, so that would be 10 to the -4th power. So that gives you an idea how powers of 10 work. Now let's look at scientific notation. Okay, remember to put it in scientific notation, we want the number to be between 1 and 10. In other words, we want to move the decimal after the first non-zero digit. So if you do not see the decimal, it's always invisible at the end. I put it here for you so you would see it. We want the decimal to be right here so that the number will read 7 and 9/10 because the number 7 and 9/10 is between 1 and 10. So we count how many places that we moved the decimal. I count in groups of 3. There's 3. 1, 2, 3, 4, 5. We moved it 5 places. That tells us how many times we're going to multiply times 10. That gives us our exponent. The number of places we move the decimal gives us our exponent for the power of 10. Now we can get rid of all of the zeros here at the end, and we are left with 7 and 9/10 times 10 to the 5th power. So now if you were to take your calculator and go 7 and 9/10 and multiply it times 10 5 times, you would come up with 790,000. Here shows the 5 places. Okay, here the decimal is invisible at the end, but we want to move the decimal between the 3 and the 4. So we read 3 and 47 hundredths. How many places do we move the decimal? There's 3, there is 6. So I know that in scientific notation, it is going to be 3 and 47 hundredths times 10 to the 6th power. I moved the decimal 6 places. That gives me my exponent. And what was the number that was left between 1 and 10 was 3 and 47 hundredths. Okay, here again, the decimal is invisible at the end. I want to move it between the 6 and the 1 so that my number will read 6 and 14 hundredths. I'm going to multiply it times a power of 10. How many? 3, 4 places. There's your 4 places. There it is in scientific notation. Again, we have the decimal at the end. We want to move it between the 5 and the 4, so it'll read 5 and 4/10, which is a number between 1 and 10. I can get rid of all these zeros. They're unnecessary. Times 10 to what power? Here's 3, here's 6, and one more makes 7. Now we have a decimal. A decimal is a smaller number, less than 10. So we know that this is going to be a negative exponent. Again, we want to move the decimal so that we have a number between 1 and 10. So we want the decimal after the first non-zero digit. So this number would read 8 and 82 hundredths. It's a decimal, so we know we're going to have a negative exponent. How many places do we move it? 1, 2, 3, 4. So we know it's a -4. I don't know why I left so much space there, but again, we have a decimal. We want to move the decimal between the 5 and the 9 so that we have a number between 1 and 10, 5 and 9/10 times how many places are we moving it? 1, 2, 3, 4, 5, 6, 7 places. So we know it's a -7. Another example. This time, we're going to have just move it after the 4, so our number is just 4. It doesn't have any numbers past the decimal. It's just 4 times 10. We know it's going to be negative because it was a decimal. 1, 2, 3, 4, 5 places. 4 times 10 to the negative fifth power. Now we're going to do the opposite. We were starting with a number in standard form and putting it into scientific notation. Now we're going to start with scientific notation and put it in standard form. If we have 3 and 54 hundredths times 10 to the fourth power, that means the same thing as 3 and 54 hundredths times 10 times 10 times 10 times 10. Every time we multiply times 10, it moves the decimal one place to the right. So we know we're going to have to move the decimal to the right 4 places. Now, if I look up here, I already have 2 digits past the decimal. So I mentally do this. I know that I have to move it 4 places. I see that there's 2, so I know I'm going to have to add 2 more zeros for placeholders. So that would be moving it 1, 2, and then 2 more. Put zeros as placeholders. And then I fill in my commas, and I see that my number is 35,400. So the exponent tells you how many places to move the exponent to the right, or multiply times 10. Here's 4 times 10 to the second power. So we're multiplying 4 times 10 times 10, moving the decimal over 2 places. Right now, the decimal is invisible at the end. So if you move it over 2 places, you have to add 2 zeros, and the number would be 400. Here we have an exponent of 3, so we're multiplying it times 10 3 times. So we have to move the decimal 3 places. I see that I already have 2, so I add 1 0, and my number would be 2,480. Okay, here we have an exponent of 6. So we're multiplying it times 10 6 times, which moves the decimal 6 places to the right. I already have 3 digits here, so I have to move it 3 more or add 3 zeros. So my number would be 6,123,000. Now let's move to negative exponents. This is dividing by 10. When you divide by 10, you move the decimal to the left so that you're making smaller numbers. So I know I have to move it to the left 4 places. The decimal is invisible right here, so the first place is just getting it from one side of the 7 to the other. And then I'm going to have to add 1, 2, 3 zeros. And that would be moving it 4 places. Here we have negative 6, so I know I want to move it negative 6, or I want to move it 6 places to the left. The first one is just getting it from the right side to the left side of the 1. So I know I'm going to have to add 5 more zeros in order to make that 6. So there's 1, 2, 3, 4, 5, 6. I have to add my 5 zeros, and there is your number. Negative 5, I'm going to add 4 zeros out front because I need to move it 5 places. The first place is just moving it from one side of the 6 to the other. Then I add 1, 2, 3, 4 zeros in front. And there is your number. Good luck on writing numbers in scientific notation.